Okay, this is part 2 of 6.1. It's really long, seems like. But anyways, number 7 says verify the following as a probability distribution and find the mean and the standard deviation. So we have to find the sum. The probabilities equal 1. And all these are between 0 and 1. So yes, it is a probability distribution. If we put this into stat edit and we do one variable stats with list 1 and list 2, the mean, which is x bar, would be the expected value. And then the standard deviation, you would get 39 and 10.4. So stat edit stat calc 1 L1 comma L2, and so you see 39 and 10.4 standard deviation. Number 8. 8, 9, and 10 are basically done all the same. So I'm going to show you 8, and then I'm going to show you the answers for all the others, and if you have questions you can ask me in class. So here they're basically telling us that these are all binomial distributions. Or binomial experiments, so we can do the binomial distributions. So it's each child born to a particular family has a 0.3 probability of having type O blood. If this couple has 7 children, then what is the probability that, those are my answers, exactly 2 of them have type O, that at least 3 of them have type O, and then it asks us for the mean and the standard deviation. So 0.3, it has a constant probability. It's independent, fixed number of trials. You're either type O or you're not type O. So yes, it passes the binomial. So N is the number of trials, P is the success, so 0.3, and Q is 1 minus P, which is 0.7. Now, if it's exactly 2, we can straight up use the formula. But before we do this, we should come over here and always start with the binomial distribution. So we have 0, 1, 2, 3, 4, 5, 6, 7, because you could have up to 7 children. That means that we have to do this formula, if you remember, for each one of these. But there's a way to do it on the calculator, and that is under second variable, binom PDF. Now be careful, don't get the CDF, get the PDF. And then you put in N, comma, 0.3, and then we want to store it, which would be arrow key, in list 1, which is second one. Now, we can see it here, and we can scroll over and look at it that way. But if you did what I showed you here, if you go to edit, they're going to be right here, and it's a whole lot easier to read. So you see it's 0.08, 0.25, 0.32, 0.23, 0.09, 0.03, and if you look here you can see what number you're on. So this is 7, and notice how it's 0.003. But if we rounded, that wouldn't even bring that up to a 1. So this is just 0 plus. And we put 0 plus because it's not 0, it's a little more than 0. So if we look here, exactly 2 is 0.32. I know you can't see that, and it's hard to see with, well, it's looking pretty good through those colors, but it's 0.32. So if we use the formula here and put this in our calculator, we would get the same thing, 0.317, which would be 0.32. Let's put this in the calculator to make sure you know how to put that in the calculator. So that would be 7, and then we go to math, arrow to prob, and then you see right here number 3, and then we put in our other side. Now if you have the newer calculator, it might have little boxes down below the C, and then the 7 would go in the box and the 2 would go in the box. I still think you have to put the 7 in first and then do the math, probability, and number 3. So here we have our 7, choose 2. Now comes our probabilities of success, so that's 0.3 squared or raised to the next power, and then our probability of failure, and this is raised to the 5th power. You can see mine, and then enter, and there's our 0.32. Okay, at least 3 have type 0 blood type, or type O blood type. Well, at least 3 means you could have 3 or 4 or 5 up to 7. So what we want to do is the probability at least 3 would be x is greater than or equal to 3, and that would be the probability of 3, the probability of 4, the probability of 5, 6, 7, all added together. So we can come over here and we can see, I believe that's what this pink is for. So all of these probabilities added together, and that would be a 36% chance that at least 3 of the 7 children have type O blood. Then it's asking us for the mean, and remember the mean is n times p. So here's n times p, and we get 2.1. The standard deviation is the square root of n times p times q. So if you take n times p times q, and then you take the square root of it, you'll get 1.2. Now, this is a little bit confusing, but it's not hard. This, to find the range, you're going to take the mean and you're going to subtract 2 times the standard deviation. And then you're going to take the mean and you're going to add 2 times the standard deviation. And that's what will go here. I believe it was parentheses. So if we say 2.1, you see right here, 2.1, this right here is a shorter way of writing this. But if you do it this way, you still have to say this plus 2 times this. And then you have to go again and say this minus 2 times this, because you have two answers here. So the mean, 2.1, plus 2 times 112 is 4.5. And 2.1 minus 2 times 1.2 is negative 0.3. And so that would be the range of usual values. That it would be very usual to have a blood type between negative 0.3. You can't have negative 0.3 kids, so that would be 0 kids up to 4 kids would be the usual range of having a 0 blood type. Okay, so that's how you do the problems. And these are all done exactly the same way. So I'm going to show you the answers, and you can work the problems and then come back and check and see that your answers are right. So here's this part. Here's A. But remember, before you do A, you want to do your table. Here's the answer to B. Now, when you see it, when it says at least, oops, right here, at least, you always say 1 minus the probability of none. And that means 1 minus the probability of 0. There it is. 1 minus the probability of none really means 1 minus the probability of 0. So that would be 1 minus 0.01, which is where the 99% or the 0.99 came from. That would be 0.17. That would be 0.20. And then your mean is 4. Your standard deviation is 1.6. And once you do your range is 1.2 and 7.2. Number 10. Here's your table. Number A is 0.22. B, which will be 0.63. He hits at least 1. That's 1 minus the probability of 0. Probability of 0 was 0, so 100% that he hits at least 1. The mean, 8.8. Standard deviation, 1.3. Your range, 6.2 to 11.4. This. Here's your table. Here's A. There's B. 0.8 is your mean. 0.85 is your standard deviation. And your range, negative 0.9, 0.25. If you have any questions, text me and I will gladly help you.